figure out the value of theta using any of these, okay? I will show all three, but why don't you choose one and see what happens? If you'd like to follow along and do all three as well, so you get used to using the buttons on your calculator, you're most certainly welcome to, okay? So in the first case, using sine, I can recognize if I take the inverse sine of both sides, that theta is going to be equal to the inverse sine of 4.1 over 7.6. If I use cosine, it's going to be equal to the inverse cosine of 6.4 over 7.6. And then lastly, it's going to be equal to the inverse tangent of 4.1 over 6.4. We're going to get an approximate angle here. I don't believe it will end up being exactly on the nearest degree, but we should get the same answer in all three cases. This time what I'll do is I'll use the other type of calculator so that you can see how you would punch this in case this is the type you have. So here what I would do is I would have to punch in 4.1 divided by 7.6 first, and I have to hit equals so that it simplifies it to that decimal. I can then take the inverse sine using second function and sine. And it says here that that should come out to being 32.5 degrees. Or sorry, 32.6 degrees. Okay? If we clarify on this one, we should match. Let's see. If I do inverse sine of 4.1 divided by 7.6, I also get 32.6 degrees. The answers are identical. And fast forwarding a little bit, you should discover that these answers also end up being 32.6 degrees. I won't show you button by button, but I think it's worth you taking the time to prove yourself that any one of these primary trig functions can be used to find that angle. The one that you choose will depend on what you're given, because you may not be given all three sides all the time. So you have to figure out for yourself, for example, if I was only given this one, which trig ratio could I use? If I was only given these two. The pairing of sides that you're given will determine for you which trig ratio you need to use. Okay. In introducing sine and cosine a little bit more to you, let's get used to using these buttons. Okay? So you'll notice on page 2 of your handout, I have you going through and finding the sine and cosine values for a number of angles. I'd like you to take a moment to punch all of those in. I'm only going to select every other one just for time. I'm going to do 0 degrees, 45 degrees, and 90 degrees. And I want you to see if you notice any patterns as you come up with these values. Pause the video if you need to calculate them. There's some really interesting things that happen here. You'll notice at 0 degrees, one of them has a value of 0, and the other one has a value of 1, and then they flip by the time you get up to 90 degrees, so starting at 0 and go up to 90. And when they're at 45, they both have the same value for their ratios. Why might that be the case? Well, we can easily explain this again by going to sort of the x and y axes. If you can imagine an angle that is 0 degrees, that means it's lying flat along here. We know that sine and cosine both involve hypotenuse in their denominators. Sine is opposite over hypotenuse and cosine is adjacent over hypotenuse. So If I raise this ever so slightly, maybe even just to a couple of degrees, this will help explain why this is the scenario. Here's our angle, and we notice the hypotenuse is right here. So when this is lying flat, there is no opposite. The opposite is going to be 0 because there's no height. So 0 divided by any length of hypotenuse is going to be equal to 0. By the same notion, if this thing is flat, both its hypotenuse and its adjacent will have the same length because they're one on top of the other. There's no height. So any number divided by itself is equal to 1. If we move this to a 45-degree angle, we have our hypotenuse here, and of course our opposite and our adjacent. Well, again, we end up with this great little isosceles triangle we talked about in the last lesson. And we notice that if we do opposite over hypotenuse compared to adjacent over hypotenuse, we should end up with the same value because these are the same, and we're dividing by the hypotenuse, which is a constant value as well. So it's not surprising that at 45 degrees, both of these have the same value. If we take a look at the 90-degree example, and maybe what I'll do is I'll take it to 89 just to give you a rough idea. Here's theta. We've got a really super, super tall opposite and a teeny, teeny, tiny little adjacent, and the hypotenuse would be here as well because it's opposite the 90-degree angle. Well, once this moves up to 90, now the opposite and the hypotenuse will be the same length because they're one on top of each other. And there is no adjacent, it's 0. So 0 divided by the hypotenuse will give us a value of 0. And the opposite and the hypotenuse both being the same length means a number divided by itself will be equal to 1. So it's just some really cool patterns that are in there. And our focus this year will be looking at sine and cosine just of angles that are in this top right quadrant. But of course, as you expand in your math understanding, in grade 11, you'll get into quadrant 2, quadrant 3, and quadrant 4, and you'll see some really cool patterns evolving in these guys too. Okay. Last example for today. Let's take a look at this one that's given to you. We've got a triangle labeled ABC. It happened to get labeled clockwise this time, which is no big deal. It doesn't matter. There's our 90. And we are given the hypotenuse value of 25 meters. And we are given that this angle here is 25 degrees. Cool that they're the same value, but not necessarily a coincidence. All right. What's really neat is that if we are given any two pieces of information about a right triangle now, it could be two sides, it could be an angle and a side, could even be two angles, we can solve for some pretty cool stuff. Okay? So here we're given a side and an angle along with the fact that there's a 90. This question says solve ABC. So first of all, what does solve mean in this context? Solve means solve for everything about that triangle that you don't know. So it means you need to solve for angle A, which is right here. And it means that you need to solve for this length AC. If you like to call it little b instead, just so it's less writing, I'm with you. That's cool. We also need to solve then for this missing side over here, which I'm going to call little a, based on the notation we learned about in the first lesson. And what I like to do when I'm given a question like this is I like to come up with a grocery list of things I need to find. And it doesn't have to be in the order of the aisles I'm going to go shopping for them, but it'll give me a checklist to follow through. All right, solve it. We're going to round side lengths to the nearest tenth and angles to the nearest degree. So which of these things do you think might be easiest to start off with first? In this case, they're all equally possible to start with, but the one that kind of speaks to me is this one. And the reason that this one looks pretty cool is that I know that the interior angles all add up to 180 degrees for a triangle. So in your solution, what I want you to do is I want you to identify what you're doing. I'm going to say find angle A. And you can just simply do angle A is 180 minus the 90-degree angle that's here, minus the 25-degree angle that we were given. And you would then figure out that angle A is equal to 65 degrees. There's one thing off your grocery list. All right, in terms of B and A, it doesn't matter which one we solve for first. Since B is listed here, let's try it, and let's find B. Now, with respect to angle B, what is little b? Is it the opposite, adjacent, or hypotenuse? Well, because it's straight across, it's the opposite. So that means when I look at my SOHCAHTOA friends, well, let's write it this way just so it makes more sense. I have to use one of them to solve for the opposite. Well, right away I can rule out cosine because it does not involve opposite at all. So now I'm down to two choices. Which one am I going to use? Well, it's going to depend on what I'm given. Do I know the adjacent or do I know the hypotenuse? Going back to the diagram, I see that I know the hypotenuse. And since I know the hypotenuse, that means I'm going to have to use sine to solve for the opposite. So let's do that. So we can say that the sine of 25 degrees is equal to opposite, which is little b, over hypotenuse, which is 25. Now, the only thing preventing me from knowing b is the fact that it's being divided by 25. So let's multiply both sides by 25. And remember that if you put the 25 out here, it's a lot less work writing-wise, and it means 25 times sine 25. So b is going to be equal to exactly that, 25 sine 25. And again, your calculator might require a times in there, it might not. Play and find out so you know in advance. Mine doesn't. And I get 10.56. Now it says in the question to round angles to the nearest degree. So because this is bigger, is 5 and higher, I'm going to round it to approximately 11 degrees. All right, or sorry, not 11 degrees. We're going to side lengths here, my bad. And side lengths are going to the nearest tenth. So instead of 10.5, I'm going to have to round it up to 10.6. And I'm going to put approximately equals 2. And this whole thing was in meters, so let's put a unit of measurement after it as well. All right, two things off the grocery list. Last one. Now, you could use Pythagorean theorem. I'm not going to lie to you. But I'm going to tell you something. Pythagorean theorem is actually a lot more work than using these trig ratios. So let me show you how we can use the trig ratio really quickly to find the length of A. So again, with respect to this triangle, how can I label this side? Is it the opposite, adjacent, or hypotenuse with respect to my angle of focus? Well, with respect to my angle of focus, A, coincidentally, is the adjacent. So if I go back up to my SOHCAHTOAs, I need to figure out which one of them I can use to find and solve for adjacent. Well, right away, sine is out because it doesn't contain adjacent as an unknown. So now I'm down to using cosine or tangent. Well, what am I given? I am given hypotenuse, and I'm going to choose to use cosine here because I'm given a hypotenuse, because just what if I accidentally made a mistake in B and then I use it as the opposite value in my next calculation? I always like to go back to the things that I'm given rather than building on previous calculations when I can. So let's set up a cosine relationship. Cosine of 25 is equal to adjacent over hypotenuse, or little a over 25. We can solve for A by multiplying both sides by 25. So A is equal to, and again, see how slick this is as opposed to writing out the Pythagorean theorem, rearranging, solving, square rooting, and so on. It's beautiful, okay? So 25 cosine 25 is equal to a side length of approximately, if I go to the nearest tenth, I'm going to have to round it up, 22.7 meters. And that's how you solve a triangle using trig ratios. I hope you find that useful. Good luck in your practice, and always contact me if you have any questions. Thanks.